Cauchy Euler equations will jump out at you because you're going to have a factor of x, and we're not used to seeing that x right here. So to solve one of these, the first thing you're going to do is you're going to assume that y equals x to the m. And then what you're going to have to do is take derivatives. Just want to make sure you know how to take the derivative of that. If y equals x to the m, then y prime will be, just use the power rule, m times 1 is m, x to the, subtract 1 from your exponent, x minus m minus 1, excuse me. So we're going to have three cases. Remember when we talked about the discriminant back in, I don't know, maybe 4.3 or 4.4, where if it's positive, you get two distinct roots. If it was 0, you get the same one repeated, and you had your complex case as well. So case 1 is where you have two unique solutions. So the way you're going to write your solution is c sub 1 x to that root plus c2 x to the other root. Here's an example. I found my first derivative. I found my second derivative. I plugged those into my dE. So you've got x squared times your second derivative minus 2x times your first derivative minus 4 times y. The next thing I did on this line is I combined the x's. You've got x squared and an x to the m minus 2. Of course, that's x squared, x to the m, x to the negative 2. When you multiply like bases, you subtract your, when you multiply like bases, you add your exponents. In this case, you have to subtract, and those cancel out, and you're left with just an x to the m. Same thing in this case, you get x times x to the m minus 1. It's just going to leave you an x to the m. On the next line, I factored out an x to the m. What I could have done was just go ahead and divided every term by x to the m, but I factored it out. I've simplified what's inside my parentheses. Simplifies to that. Factored. And now I'm going to divide everything. I'm going to divide both sides by x to the m because that can't be 0. I got two roots. This is how I write my solution. There's my negative 1. There's my 4. Let's move on to case 2 where you have repeated factors. Your repeated factor will be represented by an ln of x. If the repeated factor was repeated 3 times, for your next term it would be ln of x squared. So let's solve this differential equation. I'll make it a little bit larger. So first derivative, that's my solution. First derivative, second derivative, plug those into my equation. I did that here. And then combine your x's here. Factor out your x sub m. Simplify what's inside. And you finally end up factoring. You get negative 1/2 showing up 2 times. The way you represent that, c1x to the negative 1/2, c sub 2x to the negative 1/2, repeated factor ln of x. And that's your solution. Let's cover case 3. Case 3 is where it's complex. Alpha plus beta I, alpha minus beta I. This is your general form. In the other section, it was e the alpha x. Here we have x to the alpha. And of course, your cosine and sine, there's where your beta is showing up. So let's solve this equation. Find your derivatives. That's what I did here. Substitute those derivatives in. So 4x squared times the second derivative plus 17 times y, which is just x to the m. Simplify, simplify, simplify. This thing will not factor. I had to use the quadratic formula. So I ended up with 1/2 plus or minus 2i. Alpha's 1/2. Okay, we're still going good. So how do I write my solutions? X to the alpha. C1 cosine 2 ln of x, C2 sine 2, that's your beta, ln of x. Example 4, this is my equation. I found my derivatives. I plugged them in. I simplified, factored. I'm in case 1. There's my y sub c. But in this example, it's non-homogeneous, and I use variation of parameters to find my y sub p. So there's your y sub 1 and y sub 2 that you will put in your Wronskian. You're going to have to make sure, though, if you look at these are the original equation. If you remember step 1 for variation of parameters, your leading coefficient has got to be a 1. So I had to divide through by x squared, and that's going to change my f of x. I found my w, which is x and x cubed, came from your y sub c. Found the derivatives. There you go. W sub 1, you have a 0 here, and this is f of x. F of x. Column 2 stays the same. Simplified and got my w sub 1. Found my w sub 2. U sub 1 prime is my w sub 1 over w. Simplified and got that. U sub 2 prime, w2 over w, e to x. I integrated my u sub 1 prime and my u sub 2 prime. You can follow the integration. And then I wrote my y sub p. Y sub p, this is, let me make this larger. This is u sub 1 times x, okay, from your y sub c. And this is u sub 2 times x cubed, that came from your y sub c. Simplified. My final solution is my y sub c plus my y sub p.